fundamental pre-inaugurate, and I took care of electronic design, electronic part of our design. And for our design, we decided to use two types of sensors, which are microphone and LCD sensors. And we didn't end up using microphones because it was interfering with other stuff, so we decided to go with LED sensors throughout. And we also used the battery backup and LCD display and keypad to make it user-friendly. And the LED sensors had an emitter and a collector. And emitter emits the signal and collector collects the signal. So if something in the way blocks the signal, it tells us that it's being blocked, which we implemented in a microcontroller. And the reason we decided to use this sensor is low battery power, and which wouldn't drain the battery when we're running on an emergency battery. And it's real quick, and when we're testing, we just put our hands like this through it, and it was detecting the whole time. And we thought it would work pretty good for our small pills and everything going through it. And we also use a sensor to see if a cup is being replaced in there. We place one sensor at the bottom of the cup and one on top, and we make sure, like we cover this part with like a metal, like something like glass, piece of glass, so the signal can't go through it. And the emitter and collector get a signal through it. And if a pill is kind of like cone shaped, so when pill goes, every time pill goes drop, it goes straight down. And it always end up in this place right here, and which block the signal. So which tell the microcontroller there's something in the pill, we send a signal saying that make sure the cup is empty before dispensing this pill, or it send a signal to RF saying that pill is ready to be taken. And we also use the LCD sensor in the middle of the pipe to see if the pill is being dropped through. It worked pretty good with the big pills, but if we use like small pills like Zyrtex or Curtin, it wasn't detecting those pills because it was in the center, and if pill fall on the edge, it's not going through it, so it wouldn't detect. But it worked pretty good with the big pills though. And to see if the cup had been replaced right, we used the switch in the back of the cup. So if the cup is out, the switch is open. So which tells the microcontroller that the cup is not being replaced, so send the user to replace the cup incorrectly, or make sure the cup is replaced. But when they replace the switch, you get closed, we send a signal saying that is everything right, now we can dispense the pills. And for the battery backup, we decided to use battery backup, which we had pre-made, like we ordered online, we didn't implement anything in. And it was 12 volts, and it had 2000 MV current, which implied to us, which was let us run it for 24-hour battery backup. We even tested it, and overnight let it run on the battery backup. It was working when we came back the next day. So it went through pretty good, and it was like I'm pretty sure it would last more than 24 hours, but we only tested for 24 hours. And since we're not using more battery, the only time we need to use battery backup for the motors, and the microcontroller need a battery backup constantly. Nothing else needed power constantly. The only time it will need a power constantly was like everything else needed power when it was dispensing. So it worked pretty good for that part. And this is where the LCD we used, and this is we got everything working. That's before we soldered everything on the board. And we even got to display our team project, everything. Everything worked pretty good. And this was a keypad we used, which allowed the user to enter the time, when they want to dispense it, how many times they want to dispense the pills. Everything they need, there was a friendly user, for everything was programmed, so if on from Monday, they would push 1 and Tuesday would be 2, so they didn't need to put typo Monday in or anything like that. And there was my cost right here, which we actually didn't use the microphone, so that's a mistake right there. Should have taken that out. And we use LED sensor. I mean, we bought that for testing, but maybe that's why it's on there. LED sensor, which we bought, we used 8 of them, and they were $20. We got it from Radio Shack. And keypad we ordered, which is $5.58, and LCD display was $34. And battery backup was online. It was like everything came up together. We didn't it was $40, good deal. And the total came out to $102. And yeah, that's all from my part. And now we'll pass it on to Mark.
Please let me know when you guys are ready.